So how do we deal with the absolute value graph of a parabola? Well, if we simplify things back down to what's really key. Well, what's key with absolute value? The key is when absolute value is positive, it does nothing, and when it's negative, it flips it. Okay, it changes to opposite sign. And the boundary again is just going to be 0. So what we really want to know is where is my inside going to be equal to 0. So we're just going to start with the parabola, the original parabola. So here's my vertex is at 0, -4. Okay. My zeros are at 2 and -2. And I have points up here. So this is going to be my parabola. It's going to be looking something like this. So what's going to be key again is where is the graph going to be positive? Okay, so I'll do the positive here in green. So it's going to be positive. And where is the graph going to be negative? Okay, where the y values are negative. Okay, and when is it equal to 0? Oops, I should change this. Positive, positive, and the boundary is where it's equal to 0. Okay, so those are my boundary points. Okay, where it's negative, it's below, and something's going to change. The absolute value will affect negatives. Where it won't change is where absolute values was already positive. Okay, so let's put in our table or plug in our values into the table of values. Okay, into our function and get a table of values. When I calculate this, I'm going to end up with 9 minus 4 absolute value is 5. 2 minus 4 is 2 squared minus 4 is 0. 0 minus 4 is -4. So now that changes to +4. This is going to give me 0. 3 squared minus 4 is going to give me +5. So really the only thing that's changed is that boundary is this point here. Okay, that was our negative. Our -4 became +4. Our boundary points are going to be at the zeros. Okay, this is where the change occurred. So when I graph this, -2, 0, yeah, same points, same points. Okay, -3, +5. Well, those don't change. +3, +5. In fact, we know that all this above is the same as what we started off with. Okay, but where things have changed then is at 0, now instead of -4, we're at +4. In fact, everything that was below now becomes positive above. So there's what my graph's going to look like. It is going to be this kind of W-shaped graph. So this is probably new, but this is what we should expect based on the properties of the function. So how would I describe this new function? Well, I have to do it in two pieces because it is going to behave like a regular parabola. Okay, it's going to behave like a regular parabola for x's less than 2, -2, and bigger than +2, just going to act like a regular parabola. When x is in between -2 and 2, it's going to be an upside down parabola. Okay, so it's going to behave differently. So we need to have domain boundaries to do this. Well, again, our domain boundaries are based on where the inside is equal to 0. So I'm just going to talk about positive inside and negative inside. Okay, so inside positive is going to behave a certain way. Okay, it's going to be what is our domain here? It's going to be when x is less than or equal to -2, and when x is greater than or equal to +2. And the function is going to be just a regular parabola, y equals x squared minus 4. It's a parabola that opens up. It's got a vertex at 0, -4. Yeah, that's right. As I plug in values between -4, less than -2 and bigger than 2, 5 squared minus 4, yeah, I don't need to change anything. The absolute value doesn't do anything to the graph there. when I think about the inside being negative now? Well, that's going to happen between here and here. Okay, so it's going to happen between -2 and +2. So what's going to happen then? Well, what does the absolute value do? It changes the negative version of x squared minus 4 and makes it into a positive by applying the negative. And when I rewrite this, we have a negative parabola with a y-intercept or vertex at +5. Yeah, that's right. It's an upside down parabola. The vertex is at +5. Oh, sorry, +4. What am I doing here? So it's going to be +4. Okay, and algebraically it works out. On the graph, it's consistent. Everything is consistent with what we know. And it explains what the absolute value is doing. It's changing negatives inside to positives, okay, with that opposite sign there. So then, what is the domain and range of this function? The domain, well, the domain doesn't change. The domain is still x is all real numbers. It changes for the different pieces here and here, but overall, the total domain is still going to be all real numbers. The range, however, does change from here to here because we can only have values. Well, yeah, there's absolute value around the whole equation, so the y values must be greater than or equal to 0. Okay, so that represents my range.